Trailing zeros. How many trailing zeros are there in 100 factorial? Well, we get a 0 when we multiply 10 with some number. So this will result in n, and I add a 0 to the end. So by that logic, we know that how do we get 10? Well, we can just have, 10, 20, 30, whatever. And we can also have 2 times 5, right? Because 2 times 5 is the prime factorization of 10, so we need 2's and 5's to create a 10 to add a 0 to the end of whatever this value is. How do we determine how many of such 10's we can compose? Well, n factorial means that it's going to multiply numbers from 1 to 100. So how many even numbers are between 1 and 100? Well, 100 divided by 2 gives 50. So there's 50 even numbers, meaning that there are at least 50 2's that we can use to combine with 5's to make 10's. What about how many 5's there are? Well, if we divide that by 5, that's equal to 20, right? So there's at most 25's. There's at least 25's in 100 factorial that we can use. So obviously there's way more 2's than 5's, so we could just consider that if we know how many factors of 5 there are, then we just count that as our answer, because there's always going to be a guaranteed 2 to go with it to turn it into a 10 and give us a 0. Now, the only reason why I said 20 is the minimum number of 5's we can have is because what does this 20 represent? It means that we can have 5 times 1, 5 times 2, ... 5 times 20. Hence, we have 20 elements here. But in the middle, we have 5 times 5, right? We have 2 5's. So basically, we undercount. We only ever counted the number of 5's here, but how many 5's are like on the second column, if you want to put it that way? Well, we have 5, 10, 15, 20, and that's it, right? Because when we have a 20, that breaks down to 5 times 4, contributing a 5. So the numbers that we can multiply this left row with that's going to contribute an extra 5 are 5, 10, 15, 20. 5 is contributing an extra 1, an extra 5. 10 is going to contribute an extra 5. Same with 15, same with 20. So we add them up to get 4. In addition to the 25's we have on this column, the right column here is going to contribute 4 more 5's. So in total, we have 24 5's to work with. And since we have at least 52's by the same token of how we got more than 25's here, there's guaranteed to be 24 2's to go with the 24 5's to create 24 10's. Now, we've counted 2 and 5, but we need to also count just pure 10's, right? By pure 10's, I mean 10 times 1, 10 times 2, and 10 times 3, etc. But do we actually even need to count it? Well, break down 10. 10 is 5 times 2. So this is included when we counted 5 times 2. This is included when we counted 5 times 4. This is included when we counted 5 times 6. So basically, no need to count the multiples of 10 again. We've already counted everything when we counted the multiples of 5. So we just need 24 10's, and that's our final result.